Hello, everybody! Welcome back to Easy Learn, and today's topic is trigonometric functions, and we're going to be doing some more practice today. If you haven't watched my trigonometric functions explanation video yet, pause right here, check the link in the description below, go understand the concept, and then come back for solving. So today's question is work out the angle A between the line AG and the plane ADHE. So if you can see, this is a specific cuboid, and within that there is a triangle. As you can see, this A is the angle that we're supposed to find, and this angle is basically trapped in a triangle that is AGH. So first thing is that I can just simply grab out my AGH for a better picture. Now AGH, the GH length is 4 centimeters and the angle A is technically unknown. And we now need to solve for A, but for that we either need this length, that is the AG, or we need the AH, because as discussed before, we know that we cannot use the trigonometric identities, that is the sine, cos, tan, if we have just one available information. We either need two lengths, then we can find the angle, or we would need one length and one angle, and then another angle and another length could be easily found. But in this one, we just have one piece of information, that is just one length is available to us, the angle is also unknown, and one of the sides is also unknown. So in order to find this angle out, I need one of the sides. Now if I go about solving the AG, that is this particular length AG, you can see that there is no piece of information given over here, here, or anywhere that would help me find the AG, which means I gotta drop this. The second thing, the second length which I could try for is AH. Now, if you notice this one, this is my AH right here. And if you see that AH has some specific information to it, that is 3 centimeters and 14 centimeters right here. Now, imagine this to be a box. And if you look inside the box, if you see it being cut into a diagonal, you will notice that this part right here would be making a 90-degree triangle, a right angle triangle, and the lengths are given to you. So let me just grab it out to give a clearer picture. So it's making something like this, where the vertical length is 3 centimeters, the horizontal is 14, and the one that you have to find is this specific length. I can just call it as my x. So this means that if I have two lengths available and it's only one length missing. Now the thing is, if there was an angle involved either here or here, then I would think about using sine, cos, tan. But if we're only dealing with the lengths and two lengths are available to us, then go back to the Pythagoras theorem theory and understand that when we have two lengths and we just have to find the third length, we use Pythagoras theorem. So we can just use the basic Pythagoras theorem formula here, that is a squared plus b squared equals c squared, where a and b, hope you remember that a and b are the horizontal and the vertical lengths, and c is always the diagonal. So our diagonal here is x, which is technically missing. A squared, you could just take either 13 or 14, completely your wish. I could just take 3 squared plus my b would be 14. So 3 squared plus 14 squared. Now in order to find my final answer, I need to isolate x. And by isolate, I mean whatever is attached with the x goes to the other side. So here I have a squared attached with the x. So when this little square travels to the other side, it turns into a square root, which means I will take something like this: square root of 3 squared plus 14 squared equals x. Now you can just write that down on your calculator and check what your answer is. So square root of 3 squared plus 14 squared gives me 14.3. Just running it off. So 14.3. So x is equal to 14.3. Now having this x as 14.3 basically means that this was my length AH, and it's this specific length. So I have now my 14.3, I have my vertical length, that's 4, I have my horizontal length, that's 14.3, and now this angle is missing. Now let's move on to the actual part of the question. So here I have a 4 centimeter, the AH that I just found was 14.3, and now I have to deal with this. So I have to find the angle. Now again, going back to some basic stuff that we're doing trigonometric functions and the fact that I have two lengths and one angle, I can use the sine cos tan properties. And within sine cos tan, I have AOH. A is the length enclosed between 90 degrees and the given angle. O is the length opposite to the given angle, and H is the diagonal or the one opposite to 90 degrees. And how to apply those? Sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. Now in this particular example, you can see that we have the length enclosed between this angle and the 90 degree, so this becomes my A, and we have this length that is right opposite to the given angle, so it becomes my O. Now if I want to solve this, I can just write down, I know now that it's opposite and adjacent, so I'll be using the tan. So I have tan theta equals the opposite, which is 4, divided by the adjacent, that is 14.3. Then if I want to find my theta or my angle, that is A, I can just take the tan to the other side. Now, once I take my tan to the other side, as discussed earlier, it becomes tan minus 1. Tan minus 1 of 4 upon 14.3, tan minus 1 basically means tan inverse. So when I type that down on my scientific calculator, make sure that your calculator is set on degrees, then you click inverse, then out of this sine minus 1, cos minus 1, and tan minus 1, I'm going to select tan minus 1. So when I write that down, it's going to be something like this, arctan. So arctan of 4 divided by 14.3 gives me 15.6, which means that my angle is equal to 15.6 degrees. That's pretty much it. Hope you understood the question. If you have any confusions, any questions, just drop them down in the comment section below. Thank you so much for watching Easy Learn. Do not forget to like, share, and subscribe. See you in the next video. Take care until then. Thank you.